Mastering the techniques of brazing and soldering are essential in producing leak-proof sealed system joints. Both techniques can be performed with oxyacetylene or air acetylene. Both techniques melt a filler metal to form a metallurgical bond. The difference between them is merely a matter of heat. Soldering is performed at temperatures below 840 degrees Fahrenheit, and because of that, requires the use of flux to ensure good capillary action. Brazing, also called silver soldering, takes place at temperatures above 840 degrees, but below the melting point of the metals being joined. The filler metals used at these temperatures on copper contain phosphorus and promote good capillary action, so brazing copper to copper can be done without using flux. The trick to creating a perfect braze or soldered joint is in evenly heating the tubing and the connection to the correct temperature without overheating. Overheating the metal causes many problems. Capillary attraction is a fundamental principle in brazing and soldering and is the basis for sound joints. When a joint is prepared and heated correctly, the filler metal will melt when it contacts the base metal, and capillary attraction will draw it into the narrow space between the pieces. It will actually fuse into the base metal to form a metallurgical bond or third alloy. Capillary attraction is a delicate force that depends on wetting to pave the way into the joint. Wetting is how the filler metal moves through the joint. A molten drop of filler metal takes the shape of a drop because the molecules within the alloy are attracted to each other, but they have a stronger attraction to the base metals being joined. So, as the filler metal enters a joint, the natural curve is broken as the alloy is first attracted to one wall of the base metal. This is called wetting. The opposite wall of the base metal is then wet by the filler metal. The filler metal then reforms its natural curve. As long as nothing disrupts this process, it continues as the filler metal travels the length of the joint. But if the metals are not properly cleaned or are overheated, wetting may not occur and the capillary attraction is lost. Most services prefer brazing because it's quicker and doesn't require using flux. Brazing is quicker because the flame is hotter. So it's important when brazing to be careful not to overheat the joint. Brazing refrigeration tubing is best done with a number 2 tip. Begin by cleaning the pieces to be brazed. Wipe oil, grease, or dirt from the tube and fitting. Then use an emery cloth, tube cleaner, or cleaning pad such as Scotch-Brite. Cleaning is critical because it removes oxides that would disrupt wetting of the surface by the filler metal. Flame adjustment is always important. When using oxyacetylene, a neutral flame is best for copper. A neutral flame is produced when the ratio of oxygen and acetylene is approximately 1:1. When a torch is lit, the initial flame contains an excess of acetylene. This flame is called a carburizing flame because it deposits carbon on the workpiece. Carbon on the workpiece would inhibit wetting. To produce a neutral flame, add oxygen until the inner feather all but disappears. Adding too much oxygen, however, will produce an oxidizing flame, characterized by a sharp inner cone. An oxidizing flame increases surface oxides that also prohibit wetting. A neutral flame is needed because it imparts no chemical reaction to the base metals. Use a filler metal that contains phosphorus. Phosphorus is a deoxidizer and makes the alloy usable without flux on clean copper. Proper heating is critical to making good joints. The majority of leaks can be traced to improper heating. The reason is simple. Joint strength and soundness depend on drawing the filler metal into the capillary space. Filler metal will not flow into the joint unless both parts are at brazing temperature. Improper heating ruins capillary action, so that filler metal just piles up around the outside of the joint. Over a period of time, system vibration will cause a leak to develop. How do you evenly heat both parts to brazing temperature? If you heat only the fitting, then you must conduct heat through an airspace, and air is a poor heat conductor. If you instead first heat the tube, you take advantage of copper's excellent conductivity and draw heat inside the joint. Then apply heat to the fitting, keeping the torch in constant motion to adequately heat both the tube and the fitting. But don't overheat. Overheating causes a variety of problems. First, it oxidizes the base metals, and the oxidation interferes with the flow of filler metal into the joint. Second, oxides inside the joint will flake off and potentially block the cap tube. Only a nitrogen purge will have enough pressure to loosen and eliminate all of those oxides. Once the parts have reached brazing temperature, apply filler metal and always apply it to the opposite side of the joint from the flame. The base metals will melt the filler metal and the capillary action will draw it into the joint. Never use the flame to melt the filler. Filler metals will start melting below brazing temperature, but will not become fluid until it reaches brazing temperature. So, if the base metal is too cool, the filler metal will stick but not penetrate. As the filler melts, watch for it to be drawn into the joints. That's a good confirmation that you have reached brazing temperature. Move the flame around the coupling to draw molten alloy into the capillary. If necessary, add filler metal to other points to fill the joint. Capillary action even works on a vertical joint. First, heat the tube, then heat the fitting. Keep the torch in motion to evenly heat both pieces. Then apply the filler metal. For joints in this position, direct the flame away from the joint to draw alloy into the joint. It's important to understand that a large buildup or fillet around the outside of the joint is not needed, nor is it an indicator of a good joint. It's usually just a waste of material. A small concave fillet is preferable, unless an additional cap is necessary to promote moisture runoff. This can be accomplished by reducing the heat and adding a fillet. Anytime you need to protect part of the tubing from the heat source, use a cold shield gel that is designed specifically for that purpose. Never wrap tubing with a wet rag on a 134A system. The heat will draw moisture into the tubing, contaminating the system.